In the second module of our tutorial, remember doing all of that math? We had a section where we briefly answered the question, why all of that math? Why did we do all those mathematical steps? Now that we've covered how frequency and density histograms are made, we're going to look at how to read them. The density histogram is particularly useful because of how many questions a person can ask about it, getting answers that are easy to understand. It's all in how a density histogram is meant to be read, which depends upon each bar's height being figured correctly and the vertical axis being correctly labeled. First, let's take a look at the following density histogram, which represents a data set showing people having access to a computer, with the people divided up in age groups. That data set was taken from a group of 109 people in a small Midwestern community in which only those who had computer access responded, indicating their ages. As we said before, the trick to making use of a correctly built density histogram is in using the label on the vertical axis. In this case, it is % per year of age. That label means that in each individual bar, a single age amounts to a certain percentage of the total. For instance, in the 20 to 30 category, the bar height given tells us that each age counts for 1.74% of the total. This means that by looking at the histogram, we can tell that about 1.74% of the people having computer access were 23 years old when the data was collected. Also, another 1.74% of the people were 24 years old when the data was collected. That 1.74% holds for all of the people surveyed who were 20 years of age, or 21, 22, and so on, for all of the ages in the 20 to 30 group. If we wanted to find the percentage of all people with computer access in the 20 to 30 age category, we could either add 1.74% for each age in that category, or we could figure out how many different ages that category holds, which is 10, and simply multiply 1.74 by 10 to find the same thing. 1.74 times 10 equals 17.4%. In this way, we can get some idea of how computer access is distributed through different age groupings of people surveyed. For instance, if we wanted to know the percentage of people with computer access who were aged from 30 to 49 years, we would use the bar heights from the 30 to 40 category and the 40 to 50 category as follows. 1.74% times 10 plus 1.28% times 10 equals 27.5%. If we wanted to know the percentage of people with computer access who were aged between 0 and 19 years, we'd use the bar heights from the 0 to 10 category and the 10 to 20 category as follows. 0.64% times 10 plus 2.02% times 10 equals 26.6%. We could even get some idea for the percentages of people with computer access who were aged from 31 to 35 years. We'd first have to figure out how many distinct ages in years were in that subgrouping. 31, 32, 33, 34, and 35 make 5 separate ages. And then we'd multiply that 5 by the bar height. 1.74% times 5 equals 7.35%. At this point, you might have come up with an important question about those numbers across the bottom axis. You could be wondering if that age 20 that divides the 10 to 20 group from the 20 to 30 group is part of the bar to the left of it or to the bar of the right of it. In other words, does the age of 20 carry a 2.02% bar height or a 1.74 bar height? In the age of 10 in the 0 to 10 category or in the 10 to 20 category? A more general question might be, how do we count the endpoints of the intervals on our categories? Here's the answer to the last important question. It is the convention that when reading a histogram, each bar includes the left-hand endpoint of each interval, but not the right-hand endpoint. This means that in the histogram, the age of 20 would carry a percentage of 1.74 instead of the 2.02. The age of 10 would be part of the bar with the height of 2.02 and not with the 0.64%. This means that when we talk about a category like the 70 to 80 category, we're talking about ages 70, 71, 72, and so on, all the way up including 79, but not 80. The age of 80 would be the beginning of the 80 to 90 category instead. This convention also applies when we ask questions using the word between, as in, how do we find the percentage of people with computer access aged between 40 and 55? As stated, that question means that we want to know the sum of percentages for all the individuals aged starting with 40 and including it, and going up to, but not including 55. Adding all of those percentages would mean adding 1.28% for each of the 10 ages beginning with 40 and ending with 49, plus another 0.92% for each of the 5 ages beginning with 50 and ending before 55. So that would include 50, 51, 52, 53, and 54. So it would be 1.28% times 10 plus 0.92% times 5 equals 17.4%. So, to make sure you understand this convention, try using the following histogram to find the percentage of people having computer access who are between 15 and 40 years of age. Then, try to find the percentage between 7 and 62 years of age. Check your findings against ours.